projects that come to mind that I've come across over the last few years. This is one by a company called PCL Construction, who was using Esri technology, combining the building information model into the site in a dashboard that's very easy to use. They were doing drone flights to understand the elevation of a project that is quite large. You can see here this site project that they wanted to manage the concrete pour for a 24-hour concrete installation comprised of 6 different locations where they were going to have pumps and trucks coming into for this very large foundation and subsurface basement concrete installation for a large hospital. So using Esri technology, using drone imagery, using the power of location, they were able to design this concrete pouring system. They were also able to understand that in this very deep foundation area that they had to build a temporary roadway to get down to the bottom. Here you're seeing the plan design for the roadway, and on top of it, you're seeing the reality capture that showed the road wasn't in the proper location. They were able to understand a potential safety risk because the temporary road structure to get to the bottom of this site was not in its proper location. And they ended up putting off this very complex concrete pour situation with a very easy to use location-based 2D and 3D tool. Another example is McCarthy Construction. This is a project in San Diego, California, where multiple BIM files were combined with the imagery and the terrain model to understand the impact of an office building and 2 different scenarios for parking. So we're seeing the reality capture of the building as it was being constructed, but then we're able to overlay the BIM, the plan design for this building, and the impact of 2 scenarios for different parking garages. Combining BIM, combining OpenStreetMap data, combined with the topography of the site, enabled the university to plan accordingly to make the least impact with the negative impact with the greatest positive impact for this project. And here's another project that I like to point out as really a great example of construction monitoring and safety. This is a bridge. What you're seeing on the screen is the existing bridge in Norwalk, Connecticut. It's about an 80-year-old lift bridge that is going to be replaced by a new bridge. And the new construction so close to this old bridge created potential seismic risks. So IoT sensors, Internet of Things sensors, were put onto the existing bridge to make sure as new construction was occurring, there would not be a negative impact. So here we're seeing with an Esri solution called ArcGIS GeoBIM, the combination of BIM data, highly detailed models that come out of BIM applications, combined with the site, modeled all the way down to the equipment room that allows the bridge to be lifted. So we're able to monitor the actual conditions of the bridge, the temperature of this lift room, and the seismic activity that would be occurring as construction was occurring right next to this bridge. So here we're seeing environmental considerations. And this next bit, we actually will see the location of the sensors on the existing bridge that are measuring the XY shift of the ground as pile driving is occurring at this site. So those are the IoT sensors in blue. And we can see the actual conditions of the bridge being moved as pile driving is occurring. This dashboard allows the construction managers to have a digital twin, a virtual replica of the physical existing structures that are being monitored in a predictable time frame. And this concept of digital twins is one that is a very important topic that is impacting the world of infrastructure and that GIS is very well suited to address. So digital twins is this concept of a virtual representation of the real world. It includes the physical objects like the bridge, but also the processes, the relationships, and the behaviors that can be measured by sensors. And GIS creates these digital twins. It brings together all of these types of information, and it uniquely does it in a way that helps combine the natural and built world and helps construction companies, architects and engineers, and owners understand their environment in ways that you couldn't do with traditional CAD or BIM. And the idea of digital twins is definitely catching hold and catching the interest of those who build and manage assets in the real world. Research conducted recently by Gartner, the worldwide analyst company, And the WGIC, the World Geospatial Industry Council, conducted research in 2023. 75% of their participants in this survey indicated that they wanted to use or plan to use digital twins. However, a very small number of them really were doing it at the time. A lot of pent-up demand and interest in the concept of digital twin, but very few organizations actually putting it to use yet, creating a great opportunity for those in the architecture, engineering, construction, and consulting industry to leverage their expertise in digital modeling, in building information modeling, and apply them to the world of digital twins. So we see these concepts of virtual replicas of the real world being applied to deliver outcome-driven, better digital transformation, falling into these 5 areas. I'm going to give a few examples of each. The first would be in the world of environmental consulting, an environmental twin, an application that visualizes climate trends and extremes, that helps deliver a score of environmental vulnerability based on the existing conditions of noise and heat and pollution. Dashboards that establish these indicators for risk that help planners understand the environmental impact and perhaps the sustainability that they should focus on for their real world built projects. We see these outcome-driven digital twins being applied to planning. Planning is where you want to overlay your major plans on top of the existing citywide mesh. You might want a base map in 2D and 3D that shows the impact of your designs, or that perhaps shows different scenarios that you want to deliver to your stakeholders, to your participants in the community, perhaps to your governors and mayors and elected officials, allowing you to create dashboards that show how accessible your plans are, the financial performance and impact, perhaps the tax revenue impact of various scenarios. And you want to deliver that in various manners, in 2D, in 3D, or maybe in these Unreal engines and augmented reality type of scenarios. In the phase of design and construction, this is where we think about our architects and engineers really doing the majority of their work, where they want to bring in the models that get generated in CAD applications and BIM applications, want to combine them with the 3D scenes that exist in the real world, perhaps wanting to connect to the ever-changing models that take place during design, but show them in context to the real world that is rather fixed. Being able to connect your Autodesk Construction Cloud or BIM 360 into your GIS world to convey this integrated visualization, this combination of plans and designs that are evolving with a built world so that you can get feedback from your community, but also share project status and issues through common dashboards. And what's really interesting is in our built world, we think about networks quite often. There certainly are networks of electric and gas and our telecommunications and water and energy, but we also have networks of transportation and networks of supply chain. And using GIS and BIM, we're able to present these networks, present their status, how well they're performing, how well we are generating electricity, transmitting it to our substations, distributing it to our community through this network twin concept, which again, GIS quite uniquely brings all these layers of information together and helps convey it to audiences of all different levels. And I would say one of the greatest beneficiaries of digital twins is during the stage of operations. The projects that we plan, design, and build might take us months or years, but they get operated for decades. And we need to be most efficient in the way we operate our assets. So combining sensors of various types, being able to predictively analyze these environments so that owner-operators of these utility environments, traffic systems, facilities of all type, assets of many types can be operated and maintained more efficiently over the decades. And we're finding great uptake in the last few years of this idea of applying digital twin concepts to built world projects for the long-term operations, resulting in better space planning, better asset utilization, extending the life of the assets that get planned, designed, and built over months, being used for years longer than they might have been historically. And underpinning these various types of twins is this idea of reality capture, reality mapping, and integrating data of many types. Here what you're seeing is the city of Vienna, Austria, generated through reality capture. What looks like photographs and video is actually a interactive 3D mesh. Now, this is a video. I can't change my view necessarily other than what the scene is presenting. But I could bring my camera anywhere in the scene. I could measure from any 2 points and have a very accurate representation. Here we're looking at San Diego, California, where Esri puts on our user conference every year. So we flew airplanes over San Diego, used those images of various angles, and generated a 3D mesh of various assets in the city that we wanted to make available to the 20,000 attendees who come to our user conference. Here we're looking at Munich, Germany. And again, what looks like someone might have taken a very long time to build very accurate 3D models that can be viewed from any angle. This is imagery generated from a combination of aerial imagery, airplanes flying at thousands of meters above ground, and drones that are flown perhaps as close as 10 meters from the buildings, brought together for this very detailed mesh that acts as a starting point of digital twins. And then we're able to combine it with other layers of information. We're able to overlay our traffic patterns. We're able to underlay our utilities. We're able to show weather patterns. And here in this last few seconds here of this demo, we're able to see color coding showing how particular buildings are used. By combining data from city planning with the reality capture, our maps now tell stories in a way that we simply could not do with CAD and BIM. So what I want to do for the next couple of minutes here is walk through a handful of presentations from projects around the world, and then we'll end it up with my colleague, Alfredo, showing some examples of projects in South and Latin America. This is a really interesting project. This is one developed by an Esri partner called Housel Levine, who focus on urban planning, urban design, and architectural presentation and modeling. Here we're seeing a first-person perspective of a city known as Morrisville in Wisconsin, United States. And for years, the city planners of this town were stuck. They didn't know whether they wanted to go with scenario A, which was 2-story buildings, or scenario B, which would be a 3-story set of structures. They didn't know whether they wanted flat facades or overhangs. And they were stuck. They couldn't make decisions because the 2D drawings that they were using didn't allow them to immerse themselves and experience what these scenarios would do. They didn't understand necessarily the financial impact of scenario A versus scenario B in an easy to understand type of environment. So Housel Levine used geographic information systems data, visualization from Unreal Engine, BIM-like concepts using a product from Esri called ArcGIS City Engine, and developed this environment that the city planners themselves could drop themselves into the space and understand. And within a 30-minute meeting, the city planners were able to come to a decision that had been stuck for 3 years. Similar kinds of capabilities, bringing the city itself into an immersive environment. Here we're interacting with the model on a desktop, but then we can place ourselves into the scene, and using virtual reality glasses, we can change the environment. We can change the time of day. We can change the weather patterns. We can change the buildings again from 2D to 3D. We can change the traffic flow from one that is high level of traffic to lower levels of traffic. And we can immerse ourselves and interact with these environments in a very natural way. We can place ourselves in the city in ways we just can't do with a BIM application, but we can use BIM content to help inform and understand the scenarios much better. Another example, this is over in Tel Aviv, Israel, from a couple of years ago. We can see the city context in a very basic manner, but we can also then see a plan for a project. And what would its impact be? How would the shading and shadow do? And then once the project is built, we fly a drone around that same site, and we can actually see what that building does look like once it is constructed. I'm ahead of myself a little bit. There we go. So this is now the scenario of that same building on its site once the building was built with the context around it. So we take BIM information and we drop it into a scene to understand the plans, but then we use our drone flight and drone planning tools and aerial imagery to understand the actual impact of a project on a site. This is a very interesting project that our Esri team in the United States, collaborated with the team operating out of Taiwan to help them do a drone flight of a port area with a pier. The pier was about to get some new buildings done on it. So we helped them fly their drones with proper drone planning. They brought in their BIM file onto this pier, and they ensured themselves that the design they came up with would actually accommodate the tide levels rising by building a subfloor that was a full 1.5 meters above water levels. They combined BIM information out of Revit with a GIS scene from Esri and drone information and aerial imagery to tell a story that gave confidence to the planners that indeed, as the water levels might rise, the pier might be flooded, but the new buildings would not. This is one of my favorite projects. This is an example of Skanska International from the UK, combining our tools that deliver surveys on your mobile device that allow construction managers to go out in the field and identify risks that might need to be known about before construction occurs. So each one of these little red markers in the scene is the location of a potential hazard. So the field workers go out and collect information. It's all location intelligent. It's a very easy to use, checkbox driven survey tool that then the construction and design managers can get back together in the office and explore these hazards and determine whether or not the design needs to change before construction occurs. The savings in cost, the reduction of job site issues is significant by combining the BIM information of the project plans with the reality of the construction site. Here's another example of that product I mentioned earlier called ArcGIS GeoBIM. You're looking at a GIS environment that's full of BIM data. That BIM data is all the way down to the individual parts and pieces of the mechanical system. And when we click on one of those mechanical devices, we see in the right side of the screen the Autodesk Construction Cloud viewer, and we see all of the artifacts, all of the drawings, all of the models, even the PDF files that help us manage and maintain that equipment that began as a GIS large view. So we don't have to explore file managers and directories and tree structures of data hoping to find a document. Instead, we zoom in on that air handling unit, we click on it, it tells us what details are associated with it without ever exploring file managers. It helps us get our digital information much more efficiently. This is a project in Peru, I believe. I was down there last year, about 6 months ago. And this is a project that is a combination, you can see, of the city context at a very large scale. You can see the roadways that are planned to be added to improve access to an airport that is being planned. You can see the rivers, you can see the roadways, you can see the different zoning. We can see a combination of BIM information overlaid on top of the imagery that we generate of this particular airport, so that the airport planners, the city planners, and even the constituents in the city itself can understand the impact of city improvement in this very easy to use web browser-based web scene. Above ground, below ground, at great levels of detail, these various building and infrastructure systems all interrelated to help improve the way we plan, design, build, and eventually operate our facilities. This next project is a very interesting one. This is in, I want to say, Saudi Arabia. It's definitely in the Middle East. And what we're seeing is this network of solar panels that are being used to develop and generate electricity for a desalination plant. So multiple systems interrelated that are mission critical to each other. The solar plant needs to be operating to generate the electricity to desalinate the water to deliver to the water system of the community in this particular region of the world. Systems of systems brought together, CAD and BIM and GIS. And what you're seeing, what looks like a network of pipes is truly that. The pipes know how they're connected to each other. The pipes know how they're connected to the tanks and the valves and the desalination equipment. It's truly a network information model, not just a pretty picture of a network. This is another very different example in many ways, but perhaps very similar as well in some ways. This is the city of New York and the bus system, the network of buses that are driving around the city. We're able to see on screen right now 27 bus lines, 339 buses. 3 of them are at alert status. 7 of them are at high risk. Up 6, 5, 4, 3. It looks like the drivers are perhaps reducing risks at one moment and then encountering risks at another. This is a real-time view of the city bus system in New York. And every one of those buses is represented in a color that indicates what level of risk it might be at, how safe the system is, whether or not there's an alert in real time. And we're able to actually click on any one of these buses and understand how they relate to the people who drive them, the accidents that may have happened around them, the repairs that have taken place. All of these as potentially disconnected data sources brought together around location. Location acts as a common denominator. Location acts as this integrator of so many types of information that historically we might not be able to connect. And we have this digital twin, this real-time representation of the bus system that is graphically presented to us, but also presented to us in this graph diagram where, like you can see here, I click on a bus and I can see when it was repaired, who repaired it, how that repair related to perhaps an issue or an incident, a true digital twin. Another example of this, I believe, is also of Peru. This was I want to say this might have been the impact of floods that occurred some years ago and some infrastructure that was put in place in response to that for water treatment and improved distribution of water to various communities. So we're looking at here Esri solution called ArcGIS Pro. Within the model is BIM content that came in from any or many of the primary BIM authoring tools like Autodesk or MicroStation or other tools. And every one of these objects that look like a BIM object on screen has all of its attributes. It's not just a pretty picture. And we can then take that BIM information and export it out to a dashboard, to one of these experience builder type solutions, so that those who need the information but may not have BIM skills have what they need at their fingertips with very easy navigation, very easy way of understanding infrastructure without being a BIM expert. This is an example of Esri using our own technology to improve our own campus. This is our latest building known as Building E. It is a combination of field inspection maps and diagrams and reports. It includes reality capture information, BIM information, environmental impacts of the project, which our facility managers put together and used to help improve the delivery of this construction project on our own campus. Here we're looking at the stakeholder management, making sure that all of the neighbors of the community who are going to be impacted by any street closures or utility outages because of our construction were informed. Here you can see a project schedule on a map and all of the critical path elements visualized in a map. Here we're looking at the reality capture. Drones were flown twice a week around this project for the extent of the project. And we're able to turn on and off those layers of information. We're able to understand how the project was built years afterwards. So if we're starting to see perhaps a leak at a particular window, or we're starting to see the building not perform to its optimal levels, we have this digital twin. We're able to peel back the layers of this historical model and understand it more with more accuracy. This is a project from some years ago now, but it still, I think, is quite interesting and important. This is the city of Paris. They conducted surveys of the usage of metro stops, both above ground and below ground, buses as well as their subways. And it helped them determine where and how large and the design thoughts behind a new train station in Paris. And as the model was generated and as it evolved both above ground and below ground, the model was incorporated into this live public site so that the users of the BIM of this train station could actually understand its layout. And then once the construction was completed, once the train station was put into use, they then did another survey to understand the impact of these additional new train stations and the improvements to train stations around Paris. I'm going to skip ahead a couple here. Want to leave room for Alfredo to show some content. But this one is interesting as well. Here we're seeing the BIM models of a water treatment plant in the Northeast United States. And you can see this great level of BIM detail, accuracy that comes in with every BIM object, highly detailed geometrically, as well as maintaining all the properties. And it's not just a pretty picture of the BIM, it's this great dashboard that can be used to understand the performance and the operations of the tanks and the valves. We can combine the BIM information with mapping information, with cameras, with sensors, creating these dashboards that ensure that our built assets are operated most efficiently. We combine Power BI with our own dashboards with these various types of information, generating these digital twins of the built world that are very much grounded on GIS. Maybe a couple more projects just to skip ahead here. I probably have more content than the time allows. This is a global engineering firm. This is a project in Canada. Roughly 10 miles of track, 14 kilometers, 15 different proposed train stations that were combined in GIS with the BIM information, with the rails that are geolocated, with the city itself, again, above ground and below ground, improving the understanding of the status of the projects from executives in the corner office to the field workers who are responsible for building and reporting on the progress of these types of projects. A collaboration and sharing site grounded on GIS. This is a project in Italy. We're going to skip this one, and maybe I'll end on one of my favorite projects, San Francisco Airport. So we'll zoom in down to the airport from the national level, all the way down to the city level, all the way down to the airport itself, which is practically the size of a small city. And what we're going to see is above ground information, below ground information, 2D CAD, 3D BIM, satellite and fixed wing imagery, as well as drone flights, used for space planning, used for the management of the runways, the lights, the stripes, delivering information that the FAA needs, as well as information that the tenants of the airport, the various shops and shop owners who are selling their products at the airport, parking management. It's one of the best examples of bringing together the collaboration capabilities of GIS, the engineering level information of CAD and BIM, to help a mission critical owner, the airport itself, understand the status of the airport, manage it, and maintain it to the greatest level of safety and optimal operations, so that if a light bulb ever burns out, you can send out your crew with the right equipment, with the right asset to change that light bulb as soon as possible. That as a new terminal is completed, you're able to manage it most efficiently, put your tenants in, make sure that the airplanes arrive most safely, and that the people, the thousands and thousands of people who are relying on this airport to get them from point A to point B, have the best customer experience possible. And so with that, I'm going to wrap up here and just remind you what I talked about at the beginning, this idea that our infrastructure assets, they are inherently geographic. They all get planned, designed, built, and operated somewhere. They are part of an interconnected, complex environment of the built world, the people and society that interact around them, and their natural environment. And GIS quite uniquely brings all this together in ways that are helping improve the way we plan, design, build, and operate our world. And with that, Alfredo, I will pass it over to you, perhaps for some local examples, and perhaps in Spanish now. Alfredo, I can't hear you. Can you unmute yourself from the Zoom?
No sé si me podrían entonces
Thanks, Mark. We are going to start projecting the mirror of Alfredo. We appreciate a lot your help. Appreciate it, and we hope to have you soon in April. Hopefully, also as a company, we believe that we are going to get and do a good job with you. Right now, we are partnered with Desiree, so it's going to be fantastic work with you guys.